Continuation of number systems. Twin primes. What is meant by twin primes? So the name itself says here twin cities. Twins means iddaru ani ardham. Twins అని ఎవరిని అంటాం, ఇద్దరిని అంటాం. కాబట్టి ఇక్కడ కూడా twin primes means the difference of prime numbers is 2. It is called twin primes. What is the definition? The difference of prime numbers is equal to 2. So then only we say that numbers are called twin primes to each other. So how many twin primes are there up to 100? 8 twin primes are there. So that list also you have to put in your mind. I will give the list also. Okay. Suppose what are the examples of twin primes? So let it be 3, 5. 3 is the prime number, 5 is the prime number. What is the difference of these two? 2 it is. So the difference of two prime numbers is 2. Then only we say that numbers, that pair is called the twin primes. It is 3, 5. So the next number is 5, 7. So 11, 13. So 17, 19. So 29, 31. 41, 43. 59, 61. So 71, 73 it is. So how many pairs are there? 1, 2, 3, 4, 5, 6, 7. So 8 twin primes are there. So this list also you have to put in your mind. So twin primes means the difference of the prime numbers is 2. It is called the twin prime. So the next one is co-primes are co-primes. So it is also called, so relatively primes it is. Co-primes are relatively primes it is. So both are same, either co-primes or relatively primes it is. So what is the definition here? Any two numbers HCF equal to 1. What is the definition? Any two numbers HCF. What is meant by HCF? It is highest common factor. HCF means highest common factor. Any two numbers HCF equal to 1, we say that numbers are called co-primes or relatively primes to each other. So what are the examples of co-primes or relatively primes? Observe a few examples of that. So let it be first example 8, 15 it is. So what is the HCF of 8, 15? 1. How can you say HCF is 1? What is the shortcut related to HCF? See here. Both the values are divisible by which number? That is called the HCF. Simply. Both the values are divisible by which number? Suppose let it be 8. 8 is divisible by 2, but 15 is not divisible by 2. Okay, 15 is divisible by 3, but 8 is not divisible by 3. So both numbers 8, 15 is divisible by only 1. So that is called HCF it is. So both the values are divisible by which larger number, that gives the HCF it is. So 8, 15 is divisible by 1. So HCF is 1. So that pair 8, 15 pair is called co-primes or relatively primes to each other according to our definition. But by observing here 8 is not the prime number, 15 is not the prime number, but that pair 8, 15 is called co-primes or relatively primes to each other according to our definition it is. Okay. So let it be another example, one prime number, another composite number, let it be 7, 15. Now again here also both the values are divisible by 1 only. So what is the HCF? 1. 7, 15 both are divisible by only 1. So HCF is 1. HCF is 1. So 7, 15 pair is also called co-primes or relatively primes to each other. So any two numbers HCF is 1. But by observing here 7 is the prime number, 15 is the composite number, but that pair is called co-primes according to our definition. Let it be both the prime numbers. Suppose let it be 11, 17. So prime number means we know it is divisible by 1 and itself only. So all the prime numbers are divisible by 1 only. All the prime numbers are divisible by 1 only. So if you take any two prime numbers, always HCF is how much? 1. Always HCF is 1 if you take any two prime numbers. So we say here all prime numbers are co-primes. Very important point. All prime numbers are co-primes, but all co-primes are not primes. That is very important note. So what is the important note? So all of you note down this. So what are the notes I will write here? All prime numbers are co-primes. So what are the important notes related to co-primes? See here. Note 1. All prime numbers are co-primes. All prime numbers are co-primes, but all co-primes may or may not be primes. But all prime numbers are co-primes. Observe few examples of that. Suppose let it be one example 7, 11. Both are prime numbers. So HCF is 1. So take any two prime numbers, HCF is always 1. Suppose 11, 17. Take any two prime numbers, HCF is how much here? 1. So we say all prime numbers are co-primes here. Okay, but all co-primes are co-primes, but all co-primes may or may not be co-primes. Suppose let it be 8, 15. So HCF is 1. These are co-primes. 8, 15 is co-prime, but may not be primes. But all prime numbers are co-primes, but all co-primes may or may not be co-prime. That point you have to put in your mind. One more important note here. Any two consecutive numbers are co-primes to each other. Any two consecutive numbers are co-primes to each other. So take any two consecutive numbers. So consecutive means adjacent values 3, 4, 4, 5, 5, 6, just like it is. So take any two consecutive numbers, always suppose let it be 3, 4. So what is 3, 4? HCF is how much here? What is the HCF? 1. So let it be 10, 11. One more example. So 10, 11. So what is the HCF? 1. Both the values are divisible by only 1 it is. So here we say all consecutive numbers are co-primes to each other it is. Okay. Now the next one is so different categories of numbers. So what are the different categories of numbers? That also I will discuss with you. So natural numbers it is. Natural numbers. So natural numbers are denoted by capital N. So natural numbers begins with 1 it is. So 1, 2, 3, 4 and so on. So up to infinity. So what is the least one in natural numbers? What is the least number in natural numbers? 1. What is the largest number? Infinity. So the natural numbers are denoted by capital N it is. So the next one is whole numbers it is. Whole numbers. Whole numbers are denoted by W. So begins with 0, 0, 1, 2, 3, 4 and so on it is. So what is the least value in whole numbers? 0. What is the least value in whole number? 0. The largest value is infinity it is. So when compared with the natural number, one additional number is there here 0. That is called whole number it is. So whole number begins with 0. Okay. Now the next one is integers. Integers are denoted by the letter Z. It contains both positive and negative values. Suppose let it be -3, -2, -1, 0. So 1, 2, 3 and so on it is. So what is the least value in what is the least value in integers? Minus infinity. What is the largest value in integers? Plus infinity. It can also be written as 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on it is. Okay, it can also be represented as a line. It is represented, it is 0. Right of this is positive values plus 1, so plus 2, so plus 3 and so on. Left of this is minus 1, minus 2, minus 3 and so on it is, minus 3 and so on it is. Okay. So the integers are denoted by z. It contains both positive and negative values including 0, that are called the integer cities. So the next one is so rational numbers. What are the examples of rational numbers? So rational numbers are denoted by the letter capital Q. So it is in the form of p by q. It is in the form of fraction where q is not equal to 0. It is in the form of fraction always where q is not equal to 0. Why here q is not equal to 0 means the division of 0 cannot be defined up to now. The division of 0 cannot be defined up to now. You take any positive value or any negative value in the denominator, but it is always not equal to 0. In the fraction p by q, always q is not equal to 0. It is in the form of p by q, that are called the rational numbers it is. So the next one is irrational numbers. So what are irrational numbers it is? Irrational numbers are denoted by the letter q dash. Irrational numbers are denoted by the letter q dash it is. So what are the examples of irrational numbers? The numbers which cannot have perfect roots. The numbers which cannot have perfect roots, that numbers are called the irrational numbers it is. Which cannot have perfect roots. Suppose let it be root 2. So root 3. So root 5. Don't say root 4. Root 4 has exact value 2 it is. The numbers which cannot have perfect root, that are called the irrational numbers it is, root 5 and so on. Pi is also an irrational number, e is also an irrational number it is. Okay. Another definition is also there for irrational number, the numbers which cannot express in the form of p by q. The numbers which cannot express in the form of p by q, that numbers are called irrational number. So what is another definition, that also I will write here. So what is the another definition of irrational numbers here? The numbers which cannot express, the numbers which cannot express in the form of p by q. The numbers which cannot express in the form of p by q, that numbers are also called irrational numbers it is. Okay, that numbers are also called irrational numbers. So why irrational numbers cannot express in the form of p by q? So rational numbers, another definition is it is terminated or repeated decimals it is. Okay, rational numbers are terminated and repeated decimal, but here cannot be terminated, cannot be repeated. Another definition is, so what is irrational number? Irrational numbers are cannot be terminated, cannot be terminated or cannot be repeated. Cannot be terminated or cannot be repeated, so that numbers are called the irrational numbers. So observe few examples of that here. Suppose let it be root 2. So what is the value of root 2? So 1.4142374 and so on up to infinity it is. There is no exact value, for root 2. cannot be terminated. By observing here, cannot be terminated, cannot be repeated. So 1.4142394 just like and so on up to infinity. So these values cannot be written in the form of P by Q. Why these values cannot be written in the form of P by Q means, observe the example. Suppose let it be 3.7. We can write it as P by Q. Why 37 by 10? After decimal 1 digit we take 10 in the denominator. Suppose 2.13. We can write it as P by Q form. 213 by. So after decimal 2 digits are there. So we take 2 zeros in the denominator. Okay, suppose let it be 1.217. It can also be written as P by Q. 1217 by. So after decimal how many digits? 3 digits here, 3 zeros it is. So after decimal 1 digit we take 1 zero in the denominator. After decimal 2 digits we take 2 zeros in the denominator. After decimal 3 digits we take 3 zeros in the denominator. Like this, any decimal can be written as a fraction it is. Any decimal can be written as a fraction by putting zeros in the denominator. After decimal 1 digit, 1 zero in the denominator. After decimal 2 digits, 2 zeros in the denominator. After decimal 3 digits, 3 zeros in the denominator. But here root 2, if you observe 1.414, so 2374 and so on. So after decimal how many digits are there here? We can't say. We can't say. So how many zeros we have to take in the denominator? We can't say. So root 2 value 1.414237 and so on cannot be expressed in the form of P by Q. Similar way, root 3 also, if you observe root 3 also, so 1.732, so 6784 and so on up to infinity. So it is also cannot be terminated, cannot be repeated. So cannot be expressed in the form of P by Q. Why cannot be expressed in the form of P by Q? After decimal how many digits? We don't know. After decimal how many digits are there here? We don't know. So how many zeros we have to take in the denominator? So we can't decide. So cannot express in the form of P by Q. So the irrational numbers cannot express in the form of P by Q. Irrational numbers are cannot be repeated, cannot be terminated. Okay, cannot be repeated, cannot be terminated. So that are called the irrational numbers. These are the examples of irrational numbers it is. Okay. Now by observing here all these types of numbers, so the next one is real numbers it is. What is meant by real numbers it is? So real numbers are denoted by the letter R it is. So real numbers are denoted by the letter R it is. Okay, denoted by R. So what are the real numbers? Both rational and irrational number together are called the real numbers. Real numbers are not the new numbers. Real numbers are not the new numbers. Both rational and irrational. Rational means we know we can express in the form of P by Q, that are called rational numbers. Irrational numbers means we know the numbers which cannot express in the form of P by Q, means the numbers which cannot have perfect roots, that are called the irrational numbers. Suppose that two types of values if you put in a single set, both rational and irrational numbers can be put in a single set, that are called the real numbers it is. So it is denoted by R. So the next one is imaginary numbers. So what is meant by imaginary numbers? Imaginary numbers are denoted by the letter I. So I square equal to -1, where I equal to root of -1. So root of negative values are called the imaginary numbers it is. Suppose observe few examples of that. So suppose let it be, we know root 25. What is root 25? 5 we know. But what about root of -25? You have to say 5 into I, where I is imaginary number, I value is root of -1. So root of -25, what is root of -25? It can be written as example observe here, root of -25 can be written as root of -1 into 25 it is. It can be written as root -1 into root 25. Root 25 is 5, root -1 is I. So root of -25 can be written as 5 into I it is. So root of negative values is called the root of negative values is called the imaginary numbers it is. Okay. Now what is meant by complex numbers it is? What is meant by complex numbers? So it is denoted by C. So both real and imaginary numbers together are called the complex numbers it is. Both real and imaginary numbers together are called the complex number. So what are the examples of complex numbers? Let it be 3 plus 2i. This is the example of an complex number where 3 is the real part and 2i is the imaginary part. Both real and imaginary is included. It is called the complex number it is. Okay. So there is also some relation among all these it is, all these types of numbers it is. So what is the relation? Observe here carefully what is the relation among all these. Okay. So natural numbers are subsets of whole numbers. Whole numbers are subsets of integers. Okay. So integers are subsets of rational numbers. So rational numbers are subsets of real numbers it is. So real numbers are subsets of complex numbers it is. Okay. So among all, which is the smaller set here? Natural number is the smaller set it is. N is subset of W, W is subset of Z, Z is subset of Q, Q is subset of R is subset of C. So N is subset of W, W is subset of Z, Z is subset of Q, Q is subset of R is subset of C it is. Among all, which is the smaller set? Natural numbers. Which is the larger set? It is complex numbers is the larger set it is. Okay. These are the different types of numbers. Okay. So in the next class, I will discuss with you P by Q forms. Okay. How can you write in P by Q forms it is? Okay. So thank you to all of you.